Hey, how's it going, Sidra? I'm going to be talking about electron beam melting, EBM, and what that is. Electron beam melting, EBM, is an additive manufacturing, AM. What that means is we're going to be adding material. Instead of removing, we're going to add more material to whatever work we're doing. Or 3D printing technology that is used to create complex metal parts and components. It is type of powered bed fusion process similar to selective laser melting (SLM) and direct metal laser sintering (DMLS), but is used for electron beam instead of laser to melt and fuse metal powder together layer by layer. EBM is particularly well suited for producing high quality, dense, and fully functional metal parts, making it a popular choice in industries like aerospace, healthcare, and automotive. Let's take a look at the beam melting process and how it typically works. Powder preparation. The process begins with a bed of metal powder, which is typically titanium alloy, or other high temperature metals. The powder is spread evenly across the build platform. Electron beam control (EBM) machines can use an electron gun to generate a highly focused and precise electron beam. The electron beam is direct at control use electromagnetic coils and deflection systems. Layer by layer deposition. The electron beam is focused on a specific area of a metal powder bed, selectively melting the powder particles. The electron beam moves into a pattern that corresponds to the cross sections of the part being produced. This process is repeated for each layer of the part, with the build platform gradually moving downwards and new layers are added. This particular equipment, I believe, is very, very expensive. Just perhaps worth mentioning. This particular, perhaps, if you're just starting out with, it's not, I guess, a bad thing to take a look at this particular way of building something. But either way, I believe there's alternatives and perhaps not the best, but cheaper ways of producing. Perhaps you wouldn't necessarily get that accurate work piece to be completed, but there are alternative, cheaper ways of manufacturing different parts, even if that would be high density materials. The ones that we mentioned already, that would be perhaps metal, and even perhaps harder or even denser type of materials that we're going to be working with. Solidification. As the electron beam melts the powder, it rapidly solidifies, fusing the particles together. This produces solid, fully dense metal layers. The process continues, adding one layer on top of another until the entire part is built. Heat control (EBM) machines typically operate in vacuum or low pressure environments to prevent contamination and control the heat generated during the melt process. This helps to achieve a uniform and consistent build. Post-processing. Once the part is fully printed, it may be required to post-processing steps such as heat treatments, machining, and surface finish to meet specific design requirements and tolerances. Advantages of electron beam melting (EBM) includes high material density. EBM produces parts with high degree of material density, making them suitable for load-bearing applications. That's what I'm talking about. But yeah, it depends on what you're looking to achieve, what you're looking to build. There are different ways of doing. I barely touch on the all options available in the industry, but that would be perhaps in terms of durability and some of the materials that if you would be required to work with, that perhaps would be one of the options to do and to deliver those projects. Excellent mechanical properties. EBM parts often exhibits excellent mechanical properties due to fully melted and fused powder particles. Complex geometries. EBM can produce parts with intricate and complex geometries that will be difficult or impossible to achieve using traditional manufacturing methods. Wide material range. EBM can work with variety of metals and alloys, including titanium, stainless steel, and nickel-based superalloys. Electron beam melting (EBM) has several pros and cons, and understanding both is important for evaluating its suitability for specific manufacturing applications. Let's take a look at both pros and cons. Pros: excellent material properties. EBM produces parts with excellent mechanical properties, including high strength, good uh, fatigue resistance, and excellent material density. This makes EBM parts suitable for demanding aerospace and medical applications. Complex geometries. EBM can produce parts with highly complex and intricate geometries that are normally challenging or impossible to achieve with traditional manufacturing methods. This capability is valuable for industries that require customized or specialized components. Reduce material waste. Additive manufacturing process like EBM generates less material waste compared to subtractive manufacturing methods where materials is often removed from solid block. Material range. EBM can work with a wide range of metals and alloy materials, including titanium, stainless steel, cobalt, chrome, and nickel-based superalloys. This versatility allows for a broad spectrum of applications. Reduced tooling cost. EBM eliminates the need for complex molds and tooling, which can be expensive and time-consuming to design and produce for traditional manufacturing process. And some of those prices are in tens of thousands. Entry level, I believe it's always changing. Just a couple of years ago, entry level molds would cost around. It depends on a lot of things. That would be about 40,000, and depends who would supply that company with the mold, right? It would be Europe based or would be Asian based, would be US based mold. That's another price tag, depending who is going to be supplying with the mold. But roughly, a price tag would be about 50K entry level molds. Rapid prototyping. EBM is well suited for rapid prototyping and small batch production, enabling quick design, integration, and testing of new concepts. For those of you who would like to learn more, I would highly recommend to purchase my book. Name of the book is Game Strategy. In the book, I'm sharing a lot of information. For those of you who are interested to find out more about current industry, where markets are right now, as well as where market's going to be within the next 5 or 10 years, what education industry is going to look like, business sectors, how to approach your perhaps in the beginning start career, perhaps working for somebody else, from there progressing, perhaps owning a business. Some of the concepts I'm trying to explain for those of you who are just starting out, as well as for people who've been with the industry for many years and you already got your own business, as well as if you got some capital and looking to invest, put that money in good use and put it into work. There's information for everyone, all that information business related, and I'm using a lot of examples to make it clear for all of you who are reading it. You can find this book in the description below, as well as Top Retailers has it. Let's take a look at the cons of EBM and what the cons are. High equipment cost. EBM machines are complex and expensive. The initial capital investment requires purchase and setup of EBM systems can be substantial, making it less accessible for smaller business. Hopefully that will change, but currently it is very expensive. Hopefully it will change. Operating costs. Operating an EBM machines involves significant energy consumption, maintenance costs, and the need for trained operators. The cost of metal powders used as raw materials can also be considerable, but it can we can make it possible. That's what I'm saying. We can make it possible. I believe there's a lot of potential in the industry. Post processing, while EBM production high quality parts, post processing may be required to meet specific tolerances, surface to finish requirements, and remove residue stresses. Those additional steps can add to overall cost and lead times. Surface finish. EBM parts often have a rougher surface finish compared to parts produced by other additional additive manufacturing methods such as selective laser melting (SLM). This may be require additional machining or finish process. Limited resolution. EBM technology may have limited in achieving fine features and intricate details due to the size of electronic beam spot, which can be affect the resolution or printing process. Uh, uh, let's summarize it. I just finished on a high note. Electron beam melting (EBM) offers many advantages, including high quality material properties and ability to produce complex geometries and reduce material waste. However, it also comes with significant costs, including high equipment and operation expenses, and may require post-processing to meet specific requirements. The decision to use EBM should be based on specific need of application and availability of the potentially what budgets and what companies and who you're going to be working with basically, and the desired part characteristics. Thanks for watching. I'll see you next one.